Hydroelectric power is one form of energy where the power comes from the streaming water. This renewable source is important for the national energy for its different applications. Hydroelectric power plants do not use up resources to create electricity or pollute the air, land, or water, and also the fuel falling water is not consumed. Hydroelectric power plants are the most efficient means of generating electricity. Dams, waterfalls, rivers, and lakes are the main locations to place the system. The device used to generate flowing water into power is turbine. Penstocks are placed at the water source, which are the means for water flow. Water flow in through the penstock and hit the turbine's blades at the exit. The water flow causes the blades to spin and turn the rotor. To generate electricity, water must be in motion. When the flowing water turns the blades, the form is changed to mechanical energy. The turbine turns the generator, then converts this mechanical energy into electricity. There are several different types of turbines, one of which is the Pelton turbine. This type of turbine is used when there is a small water discharge, with a large available water head on the water. The turbine is usually designed for vertical water flow, which transfers potential energy into electricity. Francis turbine is another type of most widely used in hydroelectric power plants. The main components of this turbine is the runner blades. The blades are designed into two parts. The lower half has the bucket shape toward the outlet where the water with high pressure makes the impulse force. The other half takes water flow at its reaction force. These two forces add up together to turn the turbine. The free flow turbine, the very common type. This is usually used at rivers or lakes where water flow is consistent and constant. New river paths will be added along the river and turbines will be settled. The water flow rate will be constantly split up into the path and then turn the turbine. Hydropower is much more efficient than other power plants, which provides up to 90% efficiency. As of 2018, hydropower generated 292 billion kilowatt hours, which contributed to approximately 7% of total electricity in the US. Although hydropower does not cause pollution to the environment, the effects on the environment might damage the turbines and as a result cause pollution. Scientists acknowledge the fact they come up with some ideas. One of them is fish passages.
One challenge of hydroelectric power is its effect on the environment and on native species. One such example is the salmon in the Pacific Northwest. Salmon spend the majority of their lives out at sea in the Pacific Ocean before returning to rivers and streams to spawn. With the addition of dams in the 1950s and 60s in the Northwest, an impediment was placed on salmon that made it more difficult for them to reach their spawning grounds. As a result, by the 1990s, it was estimated that 9 out of 10 species of salmon in the Pacific Northwest would go extinct. In order to help improve salmon populations, a series of improvements have been put in place to allow more salmon to reach adulthood. The earliest method of improvement was the use of barges and of trucking to get salmon around the dams. Salmon would be manually collected and sent up to the different stages of the river. Unfortunately, this is the least effective method, and it helped to contribute to the diminishing populations of salmon through the 1900s. One more effective use of improvements that allows salmon to make it upstream is the use of fish ladders, as shown here. Fish ladders provide a series of incremental steps for salmon to slowly make it up and over the dam to the next stage of the river. Similarly to how they would climb over natural waterfalls, salmon can jump from level to level to make it to their spawning grounds. These fish ladders have a series of different locks and twists and turns which allow places for the salmon to rest on the way up. In addition to allowing salmon to get over, these fish ladders help scientists to track the number of salmon that are making it upstream. This can help scientists determine whether the amount of salmon making it to their spawning grounds is unusual for a given year. One other improvement used in more difficult to reach areas is the salmon cannon developed by a company called Whoosh. Essentially, the salmon cannon is a soft vacuum sealed tube which allows salmon to be transported up and over especially tall dams or through regions where it's more difficult to use traditional methods. The salmon cannon is one example of how modern day technology is helping to solve these age-old problems. In addition to adult salmon making it over the dam, juvenile salmon have to make it through the dams to return out to the ocean. If not presented with other methods to get around the dams, these juveniles would have to go through the turbine intakes, where a large number of them could be killed by the turbine itself. To get around the dams, a series of bypass channels is usually created for these juveniles, so that they can get around the turbine without having to go through the dam. Other improvements to help juvenile salmon include this spill wall right here. Improvements such as the spill wall help direct juvenile salmon away from shallow areas towards deeper and faster flowing waters. This improves salmon juvenile survival rate by directing them away from these shallow regions where opportunistic predators wait for an easy meal. These additions, in addition to hatcheries along the Pacific Northwest, have greatly helped to improve salmon populations over time. Using these improvements and other ideas that we come up with, salmon populations look to have a sustainable future. Listed are the sources that we used for this video. Thanks for watching, and we hope that you found it informative.